150 divisible by 5? You say?
No.
Yes.
No, yes.
Okay, the rule for 6 is if it's divisible by 2. Oh, I almost wrote it wrong.
And 3.
2 and 3. If you got a yes for 2 and 3, if it's an even number that ends in 0, 2, 4, 6, or 8, when you add up all its digits, they add up to a number divisible by 3, then it will also be divisible by 6.
Wait, what?
If it's divisible by 2 and 3, then it's also divisible by 6.
Or what if it's just divisible by one of them?
Then it's not divisible by 6. It absolutely is not. The rule for 7 is so long and such a pain that, honest to God, it is better to do the long division or go find a friend with a calculator. Okay, there is no good rule for 7. There's no good rule for 7. There are rules for it. Someone showed me once. Gave me a headache. I said no. Okay, the rule for 8 is similar to the rule for 4, but
It's obnoxious. I hate it. Don't even teach it. It's not worth teaching because it's not a trick. It's just obnoxiously annoying.
it is. But it's the last 3 digits form a number divisible by 8. So really, unless it's something like 1,212,064, and you look at the 064 and you ask yourself, is that divisible by 8?
It is.
Yeah, then the whole thing is divisible by 8. The rule for 9 is a lot like the rule for 3. A number is divisible by 9 if the sum of all the digits is divisible by 9. The rule for 10 is if it ends in 0. I'm not writing that one. And there are rules for 11, 12, 13, etc., but we're not doing them.
There's
Okay.
rules for those? I've never read them.
There's rules for everything.
Okay, well, yeah, but not
I mean, just
7.
because
There's no rules for me.
in order to get a PhD in math, you have to say something at least sort of new, which means, believe me, someone has looked at all of this stuff in order to get their PhD at one time or another. Also, in the pre-calculator days, the geniuses knew all these rules and would have to use them instead of a calculator. If you were a mathematician for a living in the 1600s, this was the stuff. This was just like your basic stuff you knew.
Well, no, I mean, this is like my basics. I know those rules, but like
But I mean, 11, 13, all the rest.
11.
Crazy.
11 is easy. It's among one of the easiest numbers.
Yeah, there's a rule for it, but it starts out under 100. It's very easy.
And then for, okay, well, 121, 132, 140, it's always like 4, like it's one
Yeah.
less, it's like 9.
Yes, it's similar to 9. 11 and 9 have similar behavior.
It's like plus 9.
But these are the rules. Okay, now, here's where you're going to use these rules, plus this prime number list. Okay? You guys ready?
No.
Take a deep cleansing breath. This is your break. Okay, moving on. Now, Nick, follow me over to this board.
Worst cameraman.
Okay.
Hold up. No, you're all good.
I'm sorry.
When you put all this together, okay, you can do things like, I can ask you to simplify. Here's an example. I'm going to ask you, without a calculator, to simplify the square root of 720. And the first thing you're going to do for that is called prime
Factorization?
factorization. Very good. You guys have all learned this before.
Oh, is that the tree?
It is a tree, but if you just do a tree, it's factorization. That's just splitting a number up into all of its factors. Factors are things that multiply together. Okay? When I put the word prime in, it becomes a specific sort of factorization. And what you have to do is go in order through your prime numbers when you're making your tree.
I know.
So, if you look at 720, your first question is this number even? Is it divisible by 2?
Yeah.
Yes. And then it's 2 times what?
Oh.
It's 360.
60.
360. Before I go further, is this the only way we could have made the tree?
No.
Now, if I'm looking at 720, maybe I'm really good and I'm going to start by doing 10 times 72. Or something like that.
You that good? Oh, okay.
Now, if I do this,
You mean 7,200.
Now 10 times 72. I'm sorry, I mean 720 up there. Thank you, Jordan. Yeah, if I'm looking at this, if the directions are just do a factorization, I can do it this way. If the directions are prime factorization, I've got to start with 2. And if it's not divisible by 2, then I go on to 3. And if it's not divisible by 3, I go on to 5. Yeah, it's also divisible by 9. There's a ton of 9 times 80. There's a ton of things I can do with this. But if I say prime factorization, you have to go in this order. So now, once again, I say 360. Is that even?
Yeah.
Yes. 2 times 180, I'll go ahead and tell you. Is 180 even?
Yes. 60, right?
90.
2 times 90. Is 90 even?
Yeah.
Yes. 30. 30.
2 times 45, but it's even. So if I say prime factorization, you go in order of the primes.
45 isn't even.
Now, no, because this is prime factorization, which means you first ask, is it divisible by 2, our first prime number? And if it's not divisible by 2, then you ask, okay, look at 45. 45 is not even. So what do we ask ourselves? Is it divisible by 2? And the answer is no. So then we have to say 3 next, and it's 3 times what?
15.
15.
Yeah, you did.
Okay?
Yay, me.
And then 3 times 5.
And then 3 times 5. And all we have left are prime factors. And this is also where those exponents come in handy. Because now I can say 720, 1, 2, 3, 4. It's 4 2s, so that's 2 to the 4th power, because that means 2 times 2 times 2 times 2
Then 3 to the second.
times 3 to the 2nd power times 5. Good. Okay, now, how does this help us simplify 720? Okay, Jenny.
Couldn't it help us simplify because I didn't think of that?
We can look for perfect squares. I'm going to rewrite it as all of its prime numbers. 2 times 2 times 2 times 2 times 3 times 3 times 5. Okay? What's 2 times 2?
4.
4, and 4 is a perfect square.
We.
So these two, when I multiply them together, I'll get a 4. What's this? 2 times 2?
There's 4.
What's 3 times 3?
9.
9.
So anytime I multiply a number by itself, I'm going to get a perfect square. Now I'm going to use that rule of splitting them up. So this is the square root of 4 times the square root of 4 times the square root of 9 times the square root of 5.
Wait, why is it not 5 to the first?
It is 5 to the first. You don't always have to write the 5 to the first, but it is. Thank you. Now, square root of 4 is 2. Square root of 4 is 2. Square root of 9 is 3. Square root of 5 is just the square root of 5. These are all being multiplied. What's 2 times 2?
4.
What's 4 times 3?
12.
So this is 12. Square root of 5 is the simplest way to write the square root of 720.
I don't get that third step.
So just
This
simplify a
one
lot.
here?
Yeah, why are you doing it again?
Square root of 4 is 2.
But couldn't you just get those from that?
Bingo, that's what I'm going to go and do next. You can. You don't have to show the step. I'm just kind of trying to show what's going on. I always do that. You know I always do it the long way first. Okay, here is my shortcut. Are you ready? We're going to go back up to this rule.
Oh, God.
Oh, upward.
I like that.
Thank you. That is actually